Hey, let's pause. Or let's keep going. Yes, you.
Wait,
Keep going.
you told me to pause and then keep going.
No. Pause the conversation. All right, so let's talk about it. First off, what was the name of the factoring method that we're using? The AC method. And so don't forget that where that's coming from is we're looking at what form to start with our factoring. Standard form. Which has what two letters in that standard form? Well, it has what letters? You said which ones?
A, B.
A, B, and C, right? One of the things I need to emphasize, I need to point out to you, the understanding check that I just passed back, we're going to go over heavily tomorrow, or more heavily tomorrow, but I want to point this out to you right here and right now. Start writing the equation above, or the general form of the equation above that equation. It's going to help you identify the different features of that equation. So ax squared plus bx plus c. Take that extra 2-3 seconds, write it above there. It's going to help you identify things. So for example, what is the a in this equation? 1. C is negative 15. And so did Alasia correctly do a times c? Yeah. To get closer to those 4 pluses, you will want to show even this information, that extra step, to show how we're getting that negative 15, more clear justification. Once you get a times c, what did Alasia do?
Yeah, find the factors.
Factors of a times c
That
add up to b. Is negative 5 times 3 negative 15? Yeah. Does that add up to this negative 2 that is the value for b?
Yeah.
Right? A times c, we need those factors that then add up to b, and then we use those factors to rewrite b. Notice, is that still negative 2x? Negative 5x plus 3x, is that negative 2x? Yeah, so she hasn't changed the equation, she's just rewritten it so that we can now, anybody remember what this is called? This part?
Terms.
Well, there are 2 terms. It's called factoring by grouping. See how Alasia grouped the first 2 together and then grouped those second 2 together? Right? That's it. And then what is Alasia identifying from this first grouping right here? Well, x is the what? Kind of, yeah. It's a common. No, it's not. We don't have a fraction. Say it again. It's a common factor. Remember, we're looking for those common factors that we can factor out. Isn't x a factor in both terms right here? X squared is literally x times x. Negative 5x is 5 times x. Do those both have a factor of x? Yes, Mr. Kitty. Thanks, guys. I appreciate it, right?
Yeah.
So, there we go. So we see an x as a factor in both of those. We factor them out, and so I'm left with x times x minus 5. So I factored out one of those x's, so I'm left with how many x's? 1. Right here, just on the inside of the parentheses, 1x. Right here, I factor out that x, so what am I left with? Minus 5. Then factor by grouping here. This is the only place I'm going to push on what Alasia wrote down. Does anyone see in this step that we would want to be careful about? She got to the right answer at the end, but there's a small mistake here. Say again. Plus. Right now, what's understood to be between this parentheses and that 3 in multiplication, right? We're not multiplying that 3. We need to recognize that we're adding that 3 times x minus 5. What we need to recognize is that we're adding that 3 times x minus 5. Good, but we do have a common factor of 3 here, so that when I factor out that 3, I'm left with just the x, and I'm left with just the minus 5. And then because the x minus 5s are the same, you've got to remember, if those are not the same, this doesn't work. But because the x minus 5s are the same, I'm able to factor that out. And when I factor this x minus 5 out, I'm left with x. When I factor this x minus 5 out, I'm left with plus 3, which is why it's important to have that plus there. And that's the factored form. Okay. What are your questions before we look at the next part of this problem?
So are we just done when we get to x minus 5 and x plus 3?
It depends on the problem. What have I asked you to do for this one? To factor. Do you have the factored form? So you're done. And so that language is important. If I ask you to factor, I'm just asking you to factored form.
Wait, is the factored form not the R1, R2?
Is this not factored form?
Wait a minute, I thought it was like the A and everything.
There is an A. What's the A understood to be? 1. Remember how the A was understood to be 1 up here?
I've seen that.
Okay.
Never mind.
Right? Max, you have a question?
Where'd you get the minus 5 from?
So remember, we needed factors of, well, we needed factors of negative 15 that add up to be negative 2. Those factors are negative 5 and 3. That adds up to negative 2. Now, I do want to pause and I want to point out one thing because there was confusion for Madison and Hudson. I think some others who weren't voicing it, but we probably had the same confusion on Friday. And it's something I talked about with third block and it helped them make a whole lot of sense out of this. Do y'all remember what I'm referring to with that confusion?
Dude, you're talking about when you tried to cancel out that X or whatever.
No, that's what you kept trying to say I was doing. I kept talking about how I was factoring the X out and there's that confusion there,
Yeah,
right?
yeah, yeah.
You were like, where did that other X go? It was still there. So one thing I want to point out is this. When we
Can you write
factor,
Can you write that bigger? I'm sorry, I can't see it.
do you don't you usually wear glasses? Where are they?
Not looking.
Yeah, it's all right, a little bit bigger. One of the things I want to point out is this. We're going from standard form to factored form. That's essentially what we're doing. What is going backwards? Like, how would I go from this factored form to the standard form? What would I do?
The opposite factor.
Well, maybe write the formula, but there was a method that we used before to go from factored form to the standard form.
You said not fully,
Or,
but the other thing.
I thought
Distributing.
Distributing is the more mathematical thing that always works, right? Distribute. So I want you to notice this, because I think this is going to help a little bit. When we distribute, I do x times x, right? That gives me x squared. X times a positive 3 would give me plus 3x. Negative 5 times x would give me negative 5x. And negative 5 times 3 would give me negative 15. Notice how what we did, and then from there, we get x squared minus 2x minus 15. Sorry, I'll get a different marker that writes better. Notice, to distribute, we went from factored form, we distributed and got how many terms?
4.
1, 2, 3, 4, right? Separated by the pluses and minuses. And then we simplified and got to 3 terms. When we factor, we started with 3 terms, then we got the 4, and then we were able to factor. So one of the things to be aware of was when we factor, we're reversing that idea of distribution, right? That's why we're getting these 4 terms here, right? And that's kind of going back to that question you had, Max. Where did that negative 5x come from? Well, when we distribute, right, we're going to get 2 different terms with just an x to the first. So we're trying to get back to that from the standard form. So when we use that AC method, Malvoria, are you paying attention? Do we need to turn desk so we can see more clearly? Because it's really hard for you to pay attention when you're not looking at the board. Guys, I can only help so much if we're not actively engaged in this. So, when I look up here, right, I'm trying to get to those 4 terms so I can group them together and factor those common terms out. Okay? So I went from the 3, I used the factors of AC to figure out what the 2 middle terms would become, right, before I added them together. So that negative 5x plus 3x came from that negative 2x, and then I was able to identify common factors to factor out. Yes, Tori?
Madison wants to know if you can write bigger.
No, I can't write bigger. Move up here. If the 3 of y'all want to move up closer, then do that. Y'all can move to a different group. That makes absolutely 0 sense. 1, you're not fine. If you're struggling that hard, move up to this closer group. All right. All right. So now this goes to what Hudson was asking earlier. He said, are we done there? If I ask you to factor, once you get factored form, you're done. But this is asking us to solve that equation. X squared minus 2x minus 15 is equal to 0. So remember, this is that first method we've been talking about to solve a quadratic in standard form. What's the first method to solve a quadratic in standard form? We're going to
Do we inverse it at last expression?
Properties of the ball.
Add 15 to both sides.
No. Look in your book. What is the first method we're going to use to solve a quadratic in standard form? The AC method to factor.
Oh.
Guys,
I thought I was
that's what I just said. That's my point. The whole point is, if it's in standard form, the first method that we're going to use to solve a quadratic in standard form is to factor. Okay. Remember, we're going to use inverses when it's in which form?
When the 0 not there.
Vertex form?
When it's in vertex form. We use inverses when the equation's in vertex form. If it's in standard form, the first method to solve is factoring, which we already did that process. When we factor this, we get x minus 5 times
X equals 3.
is equal to 0.
Wait,
Say it again.
Now you gotta make 2 equations.
Now we gotta make 2 equations using what property though?
Properties of the ball.
Inverse operation.
Yo, why are you looking at me and not looking at your notes in the book?
What page?
I didn't feel like doing all that flipping. Well, we don't feel like learning then. Guys, use your resources. Come on. Huh? Oh yeah, 81. What property?
Zero product.
Say it again.
Zero
The
product.
zero product property. Guys, that's important to recognize because the whole idea is if I am multiplying 2 numbers and that product equals 0, what do we know about those 2 numbers? At least one of them has to equal 0. That's the beauty of factoring is once it is factored, I know that either x minus 5 equals 0 or x plus 3 is equal to 0. If you do not know that zero product property, you are going to miss easy points on the understanding check and on the test. Like I'm telling you right now, you need to highlight that, you need to star it, you need to create little fireworks that come off of that zero product property. You got to know that one. Don't know yet. No, I'm just going to give you a test and not care if
When's our next
I
one?
see your understanding before the test.
When's our next? Oh.
Okay, so what would I now do to solve these equations? Right. Now I can use my inverses. You need to hear me very clearly on this. Do not use inverses when the equation's in standard form. Do not use inverses when that equation is in standard form. Is that clear?
Didn't we just say it was only in vertex form?
Because you can't solve it that way. Huh?
Didn't we just say it was only in vertex form?
Only in vertex form to use inverses. I'll show you in a second, but notice I'm creating a 0, x equals 5, x equals negative 3. Okay, so for those of y'all who want to try to solve a quadratic in standard form, you're going to try to use a, don't do this. Please understand I'm showing you exactly why you don't want to do this. Now I've got x squared minus 2x equals 15.
You have 2 x's together.
You have an x squared and you have an x. How are you going to use an inverse at this point? You can't. You might try to take a square root, but remember whatever you do to one side of the equation you have to do to the other. Do you know how to take the square root of x squared minus 2x? No. You cannot use inverses to solve a quadratic in standard form. Alright? So, I feel like we need at least one more practice problem. Yeah?
Yeah.
Before we start moving. So here is 1.8. What is the factored form of 2x squared minus 11x plus 14? Let's try to get this done. You have the chalkboards available. You have sheets of paper. I will try to get some more expo markers soon so y'all can use those. I just don't, we haven't gotten our school money yet. But let's get this factored. factor.
I think it should.
Remember, this is a good time to actively collaborate, talk with each other, help each other grow and get better at these skills. I got you. Let's do what we can. I hear you. Okay, so Jackson, you were gone Friday, right? Okay, so were you able to follow any of the beginning information? Because the beginning is the part that you have to remember the most, and the rest of it flows pretty naturally. So what's the name of this factoring method? Do you remember that? So we're going to use the zero product property, but what I called this was the AC method, because that's based on the idea of ax squared plus bx plus c. So you're going to take that value of a. What is a? 2. Wait, what's c? So we need factors of that 28 that add up to -11. So talk about that with your group, see what factors we can find that add up to, now, what is a again for this problem, Brantley? Sure? It's been 1 up to this point. Look at that equation again though. This is why you want to write the equation above it. Don't just write it here, write it above this equation. Come on, let's keep working. You don't have to keep going once you find it. Do we agree negative 4x minus 7x? Did you actually talk with them? Oh, you're sure to agree? Check with each other. But Matt, let's each other. She'll move it. And there's 3 other desks.
No, I know.
Let's move up to row 2, at least for today. It's not down. It's okay. I'm just trying to help you learn. Correct. So you can only factor out x. Now, so you, what happened to your 2x squared? Yeah, you can't just drop that on. How's your eyes burning down? You go to the bathroom?
What's the other any version of 14 times 2? No, up to 14 2. Can you add?
If you subtract x from there, isn't there a 2? Then we learn to grow together. Do you know how you can check to see if this is correct?
The inverse.
Okay, you could do that. But am I going to be there when you work on homework? Am I going to be there when you're doing a test? AJ is 100% right. I ain't doing it for you. How can you check? I'm going to give you the same exact advice. AJ, you're really close on a lot of this, but you forgot that it's 2x squared. It looks like you're actually trying to use a method that can work, but it's a little bit different than I am. Who do you have for us? Okay. I got you. So did you take this 2 and literally multiply by 14? Okay, you got that? So this can work, but when you do that, this is why I don't teach this method. You actually have to go back in once you get to here, and you have to divide by 2. It's called a slip and slide method or something like that, and you get x minus 2 times x minus 7 halves, and then you have to do x form, and you actually bring it It can work, but this is honestly just going to make your work harder. It's easier at first, just to make your job harder. You can still use this, right? That's just going to be hard. So it would be 2, but I would do this one, 2x squared minus 7x squared. And that way you don't have to do this extra. Then you have to
You don't have a ball catching it, it's not so bad.
just go, still use that if you want. Right? Factors of 28 that add up to -11, that's all that's helpful.
Because if you don't,
So we're getting there with that method, it's just a little bit different. Yes, Max? Yeah. So if you factor a 2 out of -4, it's like you're dividing it out, right? So you'd be left with a -2. Right? Okay. So one thing you don't want to do this because it's not this is negative. Now multiply 2x squared, and this is a common thing that students do. That's teachers do as well. But this is why I go like this to group instead of putting parentheses, because that literally looks like so when you look here, you can say, hey, 2 and 4, they both have the 2 in common. X squared and x, they both have an s in common. So I factor out the 2 that's gone, I factor out one of those 2 x. When you say yes, I'll say yes. Yeah, I factor out the positive 2. Everybody say yes. 2. And I factor out the find what those 2 have in common. No.
And then right here, do you do?
Thank you. Thank you. Thank you. So here's the thing, a lot of us are actually getting that first part started correctly, and please hear me very clearly on this. There are multiple other ways to factor. I'm teaching the AC method specifically because it will always work, okay? But there are other ways to factor. It's just you will have to memorize extra steps. Note, and I think most of us already have seen this, that minus 4x, minus 7x, that's what we need inside the middle terms. Do I need to clarify why for anybody? Okay. Do I need to clarify why this needs to be minus 7x and minus 4x? Either one of these will be correct. Because one thing I'll point out is I saw AJ doing this, and I've seen this from other teachers, and this can work as well, where you do a times c right here, right? 2 times 14 is 28. And then you put the -11, that value for b right here, and you just find factors of a times c that add up to -11, and that can just help you organize it. I just don't organize it that way, but that can work to help you identify what those factors would be. Does that, for if you're doing that, you don't have to do that, but if you're already doing it, that's just confirming that detail, right? So minus 4x minus 7x.
That's just the way I was taught.
Right.
Miss Moore did it.
Right, but that's exactly the same thing. Right, and I just want you to see that is exactly the same thing, it's just organized differently, right? That's all it is. I just don't use that organizational tool. Okay, so from here though, one thing I want to caution you, because Colin did this and I love this mistake, and I've seen students make this mistake in the past, be careful about this. Colin, you did this, right? And that's grouping. But does anyone see the problem when you make this mistake? It looks like you're now multiplying those groups, right? Don't do this. Please don't do this, because it looks like you are multiplying already. You don't have the factored form yet. You need to, this is why I either underline or I kind of do this to really group like that. So whichever way you go, it'll work. What do 2 and -4 have in common as factors?
2x.
They both have, well, just the 2 and -4 have a 2, and x squared and x have an x. So when I factor out the 2, that's gone completely. When I factor out one of those x's, I am left with x. And then when I factor out that x, it's gone completely. If I factor out a 2 from a -4, hear me clearly on this, this is going to help. When you factor, it's like you're dividing. What is -4 divided by 2?
-2.
-2. To clarify why I say it's like dividing, when I distribute, what operation are we doing? Multiplying. So when I factor, I am dividing. It's the inverse operation. When I look at the second set of terms, what do those have in common?
7.
Oh, snap.
-7.
Okay, so if I factor out a positive 7, pause and notice, I'd be left with a -x plus 2. Do these now match? No. That's why someone said over here we want to factor out a -7,
Positive x.
and so that would leave me with a positive x and a -2. Now what do these two terms have in common? X minus 2 times
2x
2x minus 7. Okay. To show that this works over here, what do 2x squared minus 7x have in common? And I'd be left with 2x minus 7. What do -4x plus 14 have in common?
-2.
A -2. And I'd be left with,
-2x.
ooh, remember I factored out the positive 2x minus 7. Now they both have a 2x minus 7 in common. They don't look exactly the same, but are those equivalent? Yeah, the factors are just switched.
-2.
Thank you. There we go. Notice the factors are just switched. Okay? Now Destiny asked me a question. I want to pose this to y'all. Destiny was like, "Hey, Mr. Kenny, is this right?" And I said, and I responded. How did I respond, Destiny? I don't remember. Okay. I responded with, I don't know. One, have you talked with your group? 2, how could you check? And there's 2 different strategies that you could use to check. Anybody know one of them?
What about going back to standard form?
Go back.
Yeah, could you distribute and go back to standard form and see if this is correct? Yes. It's not my favorite, but it definitely works. Anybody know of another strategy?
Graph it on the calculator.
So, well, be careful. I like that idea, Gabby, but notice, is this an equation?
No.
So we can't introduce an equal sign. Does that make sense? So I can't just put an equal sign because there is no equal sign in the problem originally. Okay, so all I was asking you to factor, but Hudson, what'd you say?
Oh, graph it.
If I graph both the standard form and the factored form, what should I see?
The same.
So 2x squared minus 11x plus 14. There it is. And 2x minus 7 times x minus 2. So, did we factor correctly?
Yep.
Yeah. What's that mathematical term for what happened to those two functions?
Oh.
They are equivalent functions and they map to each other. You're right? They're equivalent functions because we know that because they map to each other. So please know when you go home, 1, I have free software for anyone who wants it of this TI Inspire calculator. If you bring in a laptop, I'll download it on there. But 2, does anyone know a free online graphing calculator? Starts with a D.
Desmos.
Desmos. You can always go on to Desmos to graph. If you have a laptop though, I do recommend getting this software so that you can practice using the calculator. It's just something I would recommend. Okay. Questions, comments, concerns? Hopefully starting to make a little bit of sense. Okay. And so, Gabby, this would go to what you're referring to. Now, what do we have in this problem? Equals 0 and asking you to solve it. When it's in standard form, what's the first method that we can use to start solving that equation? The AC factoring method, right? Or just factoring in general. Again, A times C method of factor is not the only one. But if I have 2x squared minus 11x plus 14 equals 0, I can factor. And now what property can I
The
use?
zero property.
The zero
Product.
product. Remember, the whole idea is that they're being multiplied. for two things to multiply and equal 0, at least one of them has to equal 0. So, do not forget, right, because then it's a very straightforward problem of solving. The whole idea is that if I factor, after I factor, I can use that zero product property to set them equal to 0. Yes, sir. You're good now.
This is Mr. Pester, Gang. He is going to be your new colleague.
Okay.
Over here.
Cool.
Yes. Let's not pull that. We got a new teacher here. From your yard.
Okay.
Oh, yeah, man. Wait.
You were sorry.
That's a new teacher.
Yeah. All right.
Left one.
Does it really matter?
No, it don't matter.
Okay, so I'm going to give you all a chance. Please listen. I'm going to give you all a chance to decompress for a minute. We'll get back to the factoring in a second from problems in the book. But before that, well, first off, please note if you have lesson 4 practice numbers 1 through 3 homework, get it to me today. It's only 10% off. Some of us already got it to me on Friday. Yes, ma'am. That's a great question. I'll look after class, or maybe when y'all are working in small groups. Okay. Okay. So we're going to look quickly at the linear, exponential, and quadratics understanding check. This is the understanding check I gave back to y'all on Friday. So please go ahead and get that out to take a couple of notes as we go over things. And then we're going to get to lesson 5 in the book. So we're not going to spend forever on this, but I am going to talk through a couple of important notes. This is the understanding check that I gave back on Friday.
Oh, I know you did.
Yes, you did.
No, I didn't.
Yes, you did.
You might be.
No, that's the one I gave back today. The one I gave back on Friday.
It's the one with a bunch of graphs.
Yep.
I don't have
It's at home. Well, then pay attention and hopefully take some notes.
Are we going over the other one?
We'll go over the other one tomorrow. Okay. We'll go over the other one tomorrow. So, please note the directions were identify each of these functions for numbers 1 through 11 as linear, exponential, quadratic.
Oh, I didn't get mine. I had one.
I gave it back to you if you took it. I know that because the only ones I had left over were Jackson's and Emery's because they were not here on Friday. But I gave the other ones back.
Well, I was on. And right. I had one other class. It would have been in the binder.
I'm gonna tell you, I don't have it because I gave it back to you.
So somebody took my stuff.
Oh, someone did take one understanding check for somebody. No, I have a scan of it. I can print it back out for you later. But
I gotta read
did
it.
someone take Alasia's because they had a later class with her? Does anyone remember?
It's not easy.
Say it
Yeah,
again.
someone said something. Who got a second? Who got a second block?
Lee is, okay. Then I don't remember. Alright, well let's look at this understanding check. Please pay attention to these things. First off, if you have a graph, what should immediately tell you what type of function it is?
Quadratic.
It's a line or
Oh.
Right, the shape. Please note, oh by the way, please note this entire understanding check was based on what single sheet covers everything on this
Linear,
understanding.
Venn
exponential.
diagram.
The Venn, yeah, linear, exponential, and quadratic Venn diagram. If you're missing some of these ideas, you can go to that Venn diagram. I would note that to myself, all right? Linear, exponential, quadratic Venn diagram. That is what's going to have everything here. But when I'm looking at a graph, what tells me the type of function? The shape. That's the primary thing. That's a parabola, so the function is
Quadratic.
quadratic. Notice the extra details of a concave down parabola. I see a line there, so the type of function is
Linear.
linear. Please hear me very clearly on this. Linear and exponential functions are easy to identify the rate of change. Always identify the rate of change for linear and exponential. So, if you did not do that, I would write on my understanding check, or if you don't have that with you right now, I would write a note to myself, if it's linear or exponential, identify the rate of change. In order to earn those 4s and 4 pluses on understanding checks and assessments, I'm going to expect you to identify that rate of change. If it's linear or exponential, I'm going to ask you to identify that rate of change. because if it's linear, what type of rate of change does it have?
Constant additive.
Constant additive, which is called the,
Very change.
what's the constant additive rate of change of a line called?
The slope.
The slope. The slope is really easy to identify. Madison, what's your question?
You know,
Okay. Still hard to see even this close?
can you say what you said one more time?
The constant additive rate of change of a line is called the slope.
No, the linear exponential.
Oh, I'm always going to expect you to identify the rate of change to earn higher value, or earn those higher values on the rubric. Okay? So again, identify that rate of change. Okay? So again, those details are there. Notice with number 4, right, how I identified different points on there, on that graph. Because identifying those points can help me identify that rate of change. We should recognize, so I'm going to come back to number 3 in a second. Right here, that shape is called a what?
Exponential curve.
Exponential curve. Do not write that is a curved line. That is not a line. You will instantly drop significantly lower on that on the rubric if you call this a curved line. That is literally an exponential curve. That's the name of it. That's why it's an exponential function. And the type of rate of change is what? Constant multiplicative. The name of it is a constant factor. Factor. Right? We multiply with factors. The easy way to identify the constant factor, which this one's a little bit harder, but the easy way to identify a constant factor, remember, you multiply with factors. So the inverse of that would be division. Take 6 divided by the previous of 9. Gives me 2/3. Take 4 divided by the previous of 6. That gives me 2/3. So what's being repeatedly multiplied? 2/3. That's how you can identify that multiplicative rate of change. Like that. Okay.
So is that what the F stands for? Factor?
F for factor, yep.
That one doesn't. Sorry. That one doesn't have a constant rate of change.
Which one?
Oh, the exponential.
I mean, is that the same thing every time?
But yeah, but what would it go down next to?
Times 2/3 again? And you would just have to recognize that's going to give me a fraction of 8/3. It's going to multiply by 2/3 again. And it's going to give me 16/9. That's the whole point, is that an exponential and a linear both have constant rates of change. Just linear is constant additive, exponential is constant multiplicative. That's why the equations are the way they are. Max?
Does the graph gradually decrease?
It actually doesn't gradually decrease, it exponentially decreases. And that's literally why it does that. Notice it might seem gradual here, right? But isn't it a very steep decrease over here? Remember when we did that dream job salary task and you were looking at, hey, I have a penny and then I get another penny, so I have 2 pennies, and I get 2 more pennies, so it's 4. That was really slow at first, right? But I think on the last day, you got 5 million extra more dollars, right? That's a huge increase. And so it may look small at first, but it's exponential. So at different points, it'll look slow, and other times it'll look really fast. That's why it's multiplicative, and that's what we want to pay attention to. That's a good question. Peyton. All right. Any questions through those? I know we still need to talk about number 3. Okay. So with number 3, there's a very simple way to tell it's not a function. Some of us refer to it. Does anyone know what it is?
The vertical line.
The vertical line test, okay? The vertical line test. If that vertical line hits 2 points, it's not a function. We should notice that. A lot of us call this quadratic, but is that a parabola? No, it's a circle. A circle is not a function. Now, I want to clarify this, and I need you to pay attention and make this note somewhere. Because the vertical line test tells you if it's a function or not, but we need to understand why. Does anyone know why that vertical line test helps us determine if this is a function?
There's too many outputs?
That's a huge part of it. Can you clarify that some?
No.
Okay.
One input and multiple outputs.
Right. Go back to the definition of a function. In order to be a function, each input of the relation, remember all of these are relations, just some of them are also functions. Each input of the relation maps to one and only one output. That's the definition of a function. But you see this one input has how many outputs?
2.
2. That's why the vertical line test works. Because if the vertical line hits more than one point, that means that that one input has multiple outputs. Go back to the definition for whether it's a function or not. Use that vertical line test, sure, but make sure you go back to the definition. I need y'all to remember, at its core, math is the study of what? Patterns and relationships. But that means that we need a common language to describe those things. Those definitions and attention to that detail matters. That's something we want to pay attention to. Okay? So going back to this definition informs us that it's not a function. Questions, comments, or concerns through number 4?
Where's my name?
No.
What do I do?
I will print out, I have a PDF of it, so I'll print it out and give it to you.
I just do it.
Huh?
I just do it again.
No, I already have it graded.
He has a picture of it.
Before I give any assignment back to y'all, I scan them. Okay. So when we look at a table, the big thing we need to recognize with tabular representations is that we need to look at the what? What's the only thing in tables? The pattern called the rate of change. That's the big thing here. Okay? When we look over here at this linear, what did most of us forget?
To write that out.
To write out the change in x. Remember, the constant additive rate of change is called a slope, which is the change in y divided by the change in x. It wasn't repeatedly adding 4, it was repeatedly adding 4/3.
So did you mark that wrong if we do a phase?
Well, that was a P for a procedural mistake, and I think you could have, it was either a 3P or a 3P plus, depending on your level of evidence otherwise. And so that's the thing to recognize is just, that's part of the rubric is as long as you justify your answers, it doesn't automatically, you getting it wrong in some way doesn't automatically knock you out, but you have to justify. You need to say, hey, it's a linear function because, and if you just say constant additive rate of change, you're missing details. That was either a 3D or a 3D plus, but you have to add in that constant additive rate of change here to earn those higher scores.
What's that word on 6? Like
We haven't gotten there yet. Stop sweating. I'm just talking about number 7 right now, okay?
You need some class.
The big thing on number 5, most of us, or some of us, I will say this, talked about multiplying by 2, meaning you were going this way. But remember, you read a graph from left to right. You go from the smaller x values to the larger x values. So it's not multiplying by 2. Some of us also talked about is dividing by 2, but hopefully with our work that we've been talking about, we're starting to remember and recognize, don't write it as times 2, or divided by 2, write it as times 1/2. Use that reciprocal. That's going to come up when we write the equation for this in a second. Okay? So I'm going to talk about that in a second, but notice we want that times 1/2, constant multiplicative, so the function is exponential. Okay? And then over here on number 6, so many of us got so close on this one, but I need y'all to pay attention. This is constant additive, correct? Plus 3 every time? But that is not the rate of change. The rate of change is only the first set of differences. What type of function has a constant additive rate of change? Linear, right? So this rate of change is linear additive. We need to recognize here that the rate of change is linear additive because that makes the function quadratic.
You looking for the number?
Huh?
You looking for the number?
You would have to write the equation of a line to get that rate of change here.
But it's 3.
No, it's not.
It's going up by 3.
No, the rate of change is this first set of differences. This informs us that the rate of change is linear additive. You would have to write an equation for that rate of change technically, and this is why I'm not having you do it. This is how you would have to write this. It would be plus 3n plus 6. That's the rate of change, 3n plus 6. I'm not asking you to do that when it's a quadratic function because we just don't have time to really hone that skill, okay? But please note and keep in mind that if it's quadratic, you will see constant additive, but that tells us that the rate of change is linear additive. That's what you needed to note there. Questions, comments, concerns through that? Hopefully I gave you all some feedback on those details. Okay. By the way, I will point this out. If you want these solutions, just let me know and I can print them out for you at some point, just not in the middle of class. But if you let me know, I can print it out before enrichment or something. Okay, the big thing here with 8 through 11. I know that some of us just picked up the calculator and graphed it, but I do want to point out, so like you could have earned some points that way. But I already gave you a section where you had graphs, didn't I? I didn't want to see if you could determine the type of function off the graph. I wanted it based on the equation here. Notice it's linear because it's got the slope-intercept form of a line. I've got the constant additive rate of change of -3. I wanted to see that you recognize it based on the equation. I think we should be more comfortable with this based on a lot of the work that we've done recently. For example, when we look at number 10, what should we instantly recognize?
X to the
X to the squared. Come on, there's more that we can say about that.
It's in standard form.
It's in standard form of a quadratic.
function.
Right. That should tell us right away. It's standard form of a quadratic function. So it's quadratic. Okay? Number 8 is linear. Are any of the other ones linear? 11. Notice some of us noted that slope-intercept just switched, and that's true. But one of the big things I want to point out, and you should keep in mind, because I didn't put point slope in here, but I could have, what makes something linear? Constant additive rate of change. What operation shows repeated addition? Repeated addition. Or multiplication. That multiplication is what told me it was linear, because that means I'm repeatedly adding what value? 3/4.
On 12, how do you get a plus bx?
You mean 11?
Yeah, same thing. A plus bx.
That's a different form.
What form is that? Is that like the same?
It's still slope-intercept, but this is traditionally how we write slope-intercept in a stats class. So notice that's still my y-intercept. That's my slope, because, and this is why I want you to focus on that multiplication is repeated addition, right? And so that's what defines that as linear. Make sense?
No, it's shaky.
Okay.
Bro. I don't like that.
All right. From there, finally, number 9, exponential. Guys, if that variable's in the exponent, it is exponential every time, all day, every day. Notice an exponent indicates repeated multiplication. So what is the multiplicative rate of change? Say that again.
2/3.
2 divided by 3.
Right. Which note that means that we're multiplying by 2 and dividing by 3 at the same time. Multiplying by 2/3. But that exponent is what indicates repeated multiplication. Okay? Or the exponent with a variable. Alright. So let's look briefly at writing the equation. One of the biggest things is we did not write out our equations. As soon as I recognize exponential, which we do need to recognize that, and we've done practice since this understanding check. If you remember, I built some bell ringers off of the mistakes I saw in this understanding check. So we want to pay attention to that, but we would want to note, hey, it's exponential. It's constant multiplicative rate of change. And so we would want to recognize, again, that variable in the exponent is repeated multiplication. That is my rate of change. What's repeatedly happening?
What did I say?
Multiplied by 1/2. I think this is number 5 on the previous page, or on the other side. And this is why you want to recognize divided by 2 is times 1/2, because that's multiplication. You want to recognize that we're multiplying by 1/2 to the x.
Is that the form for exponential?
Yes, ma'am.
A times b. You know,
Raise to the x. Do you know where you can find that form?
come up with a diagram.
Uh-huh. Yep. With all those different features defined. And then please understand, guys, I'm not trying to be smart alecky. I'm trying to point out, use your resources. If I go over something I ask you to write in your notes, it's because you need those notes. Go back to them. Okay? And then A would be my y-intercept, which is 2. Notice how I identified it clearly. And so Madison, the other thing, remember how you're like, where did A plus bx come from?
Yeah.
Notice that matches A times b to the x, where A is the y-intercept, b is my rate of change.
So that's just half of that thingy that we were doing earlier.
I don't know what you just said.
That's half of that thing we doing earlier.
Half of what thing?
Like-
No, because those are quadratic equations. Exponential and linear. You have to keep those letters separate. Okay? I got you now. Alright. For linear, I'm not going to spend as much time. The big thing was you had to identify your slope. Remember, rise divided by run, or change in y divided by change in x. And you need a y-intercept. The one thing I will point out on the linear is you did very clearly have a y-intercept. That was not a clear point. If you look again, that line does not hit the intersection of the grid. You had to go down to this point or go up to this point. And that's what messed a lot of us up. And I saw the same numbers for a lot of us. I think a lot of us did negative 2/3. But some of us justified it, so I was able to award you points on the rubric. But if you didn't justify where you got that negative 2/3, I couldn't give you anything. If you don't justify and you get the answer wrong, it's automatically a 0 minus. I can't award incorrect answers. I can reward correct ideas, though.
You know, there's
We were talking about that on intercept.
Huh?
You said it on intercept.
Yeah. That's the wrong sheet, Madison. Yes, Max.
I got the right answer, I just didn't have any of that for it.
Did you put one? Did you get a 1 plus?
No,
0
I got
minus.
0 minus for all.
What did you write for the equation?
X equals negative 3.5.
Where's your x?
Oh,
Again, guys, and like that's the thing that kills me is the rubric very clearly says if you get the wrong answer without justification, it's a 0 minus, and there's nothing I can do about it. The expectations are there, and it kills me when I see that, Max, because I know that you understand ideas, but that's the rubric, right? So again, justify your answers, and 2, remember if you write out y equals mx plus b, it's going to be way harder to miss that x. Okay?
I was actually saying like turn in, we were just like writing some steps on them.
Okay. Alright. So, let's get back to the book. That's a break there on linear, exponential, and quadratic. If you need to review any of that, the video will be on YouTube today. I will, the video on the Venn diagram is already on YouTube. I have tutoring hours. I want you to be successful. Take advantage of those resources. Okay? But let's get back to the root of the problem. So what we're learning about with this lesson 5, the root of the problem is doing what?
Oh, dang.
Finding the root of the problem.
Yeah?
Solving quadratic.
There we go. Solving quadratic equations. The solutions of quadratic equations must tie into the what that Hudson was referring to?
The roots.
The roots, right? Those solutions must tie into the roots. We'll connect to that more clearly later. And we talked about it here on the getting started, right? Here on the getting started, if you have vertex form, what are you going to use to solve? This is the getting started. The getting started page.
We already did all of it.
I'm aware, I'm reviewing, recapping.
Oh,
Say it again.
If you have a vertex form, you're going to use
The inverse operation.
inverse operations. Is that what you're saying, Gabby?
Property of equality.
Sure. Okay, so inverse operations with properties of equality. Now, I want to point out we left this earlier. Oscar did not use the properties of equality in inverses. What did Oscar do? He got his equation into what form? He got into standard form, and still that's kind of a vertex form, but 0 is equal to x squared, and we can say plus 0x minus 36. And I'm going to pause, I'm going to point that out. If we're missing that 0, or we're missing the bx, it's understood to be what? 0x. This is a special type of quadratic that we're going to talk about the name of in a second, but I first want to point out the AC method will still work. If you write your standard form out like this with that 0x there, what is my A?
0. Oh, 1.
The A is 1 times the C of negative 36 gives me negative 36. So I need factors of that add up to be
0.
0, which would be?
6, negative 6.
And so this is not the most efficient method, but it still works is my point. What do x squared and 6x have in common?
X.
And I'm left with x plus 6. Negative 6x minus 36 have a minus 6.
X minus
If I factor out the negative, it becomes positive.
So you got x plus 6 and x minus 6.
So x plus 6 times x minus 6. And he used what property from here? How do you go to two equations? Zero product property. Okay. This is a special case though. So notice, can you still use the AC method to factor?
Yeah.
100%. This is a special case though that is actually significantly easier to factor. X squared minus 36. It's called a difference of squares, right? Notice a squared minus b squared. You see how it's literally a difference of two things being squared?
Yeah.
Well, literally we have x squared. Is there a way to rewrite 36 as something squared?
Negative 6 squared
Or just 6 squared? If you ever have this difference of squares, it's always going to factor, let me erase this, as a plus b times a minus b. So x squared minus 6 squared, x plus, notice a and b. What is my b in this case?
X plus 6.
So x plus 6 times
X minus 6.
x minus 6. That's how a difference of squares will always
I
factor.
don't need to make a switch for real.
Huh?
I don't need to make something for real.
So what?
Okay, I'll talk through other details in a second. But I'm pointing out, first off, I want you to understand, can we always use the previous method we did? Yes. This is just a quicker thing if you note it. Okay? And I'm just telling you that it works for now. I'm going to show you why in a second. What's your question, Elijah?
Well, okay. You got minus 6 and 6, negative 6.
No. Remember, it is called a difference of squares. So that minus just makes it a difference. Okay? If it's a squared minus b squared, it's always a plus b and a minus b. Every time.
Is there an equation for this?
Yeah, it's called a difference of squares. It's a property. The reason why it works is if I were to distribute it back out, what's x times x?
X squared?
X times negative 6.
I don't know.
X 6.
Oh, yeah, yeah.
And then 6 times x.
6 and 6.
And then 6 times negative 6.
30.
Negative 36.
So notice the x times the x gives me x squared. Because 6 and negative 6 are the same, that gives me the 6 squared. But what happens in the middle? Creates a 0. That's called that difference of squares, and that's why it always works. Now, you don't have to know that. You can always go back to the AC method. This just speeds it up. Yes, Max?
If you realize that you have an x squared in 36, did you not just square? happen if you square both of those?
What do you
Like,
mean?
Cancel out the x squared and 36.
You mean square root?
Yeah.
Well, you can't because remember, if you square root something,